For the last 2 years, working with AI has meant acting as the engine yourself. You type a command, wait for a response, and then type the next one. It is a manual process where every step requires a human to press enter to keep the momentum going. Boris Cherny, the head of Claude Code at Anthropic, noticed a change in his own workflow. He realized he wasn't writing individual prompts for Claude anymore. Instead, he was writing small systems that run in the background, figure out what to do, and then prompt the AI for him. Look at the AI stack. At the bottom is prompt engineering, the words you say to the model. Above that is context engineering, managing what the model sees. Then harness engineering, arming a single run. Finally, the top layer, loop engineering. This video will show you how to build that top layer. We're going to construct a system that finds its own work, writes the code, grades its own homework, and remembers its progress using standard command line tools. When you move from prompting to loops, you are no longer the operator of the agent. You become the designer of a system that regulates itself, leaving you to focus strictly on defining what the end goal should be. The first requirement for an autonomous system is the heartbeat. For a loop to run without you, it needs a schedule. It has to be able to wake up and start working without a human intervention. You can set this up with a simple cron job or a specialized command like /loop5m. This command starts the cycle and tells the system exactly how often to check for new tasks. Once the system is awake, it needs discovery. Instead of you telling the AI what to do every morning, the loop needs to be able to look at your environment and find work worth doing on its own. You can achieve this by pointing the heartbeat at a skill file, like a morning triage script. This file instructs the system to scan your GitHub issues or look for failing paths in your CI pipeline. But there is a risk here, the amnesiac loop. Most AI agents start every session with a fresh context window. Without a way to save data, the agent will wake up, see the same failing test, and try to fix it from scratch every single time the heartbeat ticks. The solution is the memory spine. As you see here on the right, we instruct the loop to write its findings to a physical state.md file on your disk. This way, the information survives even after the agent's session ends. The state file acts as the loop's long-term memory, logging which issues it found, where they came from, and tracking the status of each fix. When the next heartbeat arrives, the agent reads this file first to see what is already in progress. By combining an automated heartbeat with this kind of persistent memory, you transform a one-time AI task into a continuous, compounding workflow. Now we move to execution. If you let a single agent write code and then ask it if the code is good, it will almost always say yes. We call this the nodding loop, and it's a fast way to fill your repository with plausible-looking mistakes. To prevent this, we use the maker-checker split. The system first spawns a sub-agent called the generator. Its only job is to draft the initial code or fix. But we don't stop there. The system then spawns a completely separate sub-agent, the evaluator. This agent is not allowed to write code. It is only there to quality check the generator's work. You have to give the evaluator an adversarial mindset. Its instructions should tell it to assume the code is broken and to default to doubt. It should never praise the output. Only look for reasons why it might fail. Because these agents are often working on different tasks at the same time, we give them isolated work trees. This ensures that two agents don't try to edit the same file simultaneously and collide. To finish the task, we set a stop condition. Using a command like /goal, we bring in a fresh model to verify that the code passes all tests. The loop is not allowed to close the task until these conditions are met. You must also set limits to prevent token blowout. If an agent gets stuck in a retry cycle, it could spend your entire budget in a single night. You protect yourself by enforcing hard caps on retries and spending before you let the loop run unattended. Finally, follow the rule of the handoff. Never auto-merge. The loop should do the work, but it must push that work to a pull request or an inbox for human review. By separating generation from verification and enforcing these hard stops, you ensure the loop remains a high-leverage tool rather than a liability. You now have the blueprint for a 6-part autonomous system: a heartbeat, a memory spine, makers, checkers, and a final human checkpoint. This shifts the economics of your work. In a world of loops, the generation of code and content becomes abundant and nearly free. What stays scarce is human judgment.
Your value as an engineer is now concentrated in the gap between what looks reasonable to an AI and what is actually right for the project. Try this yourself. Deploy a small triage loop on a safe repository tonight. Set your spending caps, walk away, and check that state file in the morning to see what it found. Loop engineering requires you to surrender the keyboard, moving into a position of oversight, fiercely guarding final authority over the system you've built.